Alright, welcome back. Here we're going to do a few examples of calculating molar masses. Yeah, let's just give this title. So we're going to calculate some molar mass. Okay, and we'll use the same exact strategy that we used in the previous video. And you're going to get good and used to this because turns out you're going to calculate a lot of molar mass. However, once you get it, it kind of flies. People like these because they're as clean as they look like they are. All right, so we did water in the previous video, and we figured out that 18.02 grams of water is 1 mole. So if you had a kitchen scale, you could put a cup on your kitchen scale, measure out 18.02 grams of water, stare at it and be like, okay, that's 1 mole of water. If we were all together, we would do this with flour, with sugar, with copper, which looks like these shiny little beads. We can do this with salt, kind of anything at all that has a molecular formula. You can calculate the molar mass. And usually I hold up a bag with a mole of flour and say, what are you used to measuring flour in? I measure flour all the time. Usually it's in cups. You could measure a mole of flour in cups also. It's about 1.25 cups-ish of flour is a mole of flour. I should say that's not exactly correct because flour is kind of a mixture of a lot of things. Flour is not pure the way that salt is pure. Sugar is actually also usually pure, like that's kind of the form that you get it in usually. So you can calculate the exact molar mass of a mole of sugar. It's a little, probably closer to 2 cups. I don't actually remember, but it's kind of in there as a mole of sugar. And we can calculate the mass of sugar. We could even, so there's this page that we're going to look at also, but we could just do sugar first. Oh, that was laggy. Okay. Great. There's this page, sugar. Here, I'll give you this. Sugar is C6H12O6. I forget if we used that somewhere else recently. Anyways, that's the molecular formula of sugar. And you've got 6 carbons in 1 molecule of sugar, 12 hydrogens, 6 oxygens. You know that a single mole of carbon is 12.01. Your video's like behind, but that's okay. Or the video. 12.01 grams per mole. In 1 mole of sugar, you have 12 moles of hydrogen. Each one is 1.01 grams per mole. There we go. So each mole is 1.01 grams per mole for hydrogen. And 6 moles of oxygen. Each mole of oxygen is 16.00 grams per mole. Multiply them out, so the 6 moles of carbon all together is 72.06. The 12 moles of hydrogen all together, and the 16 moles of oxygen, try again, the 6 moles of oxygen, each one of which weighs 16 grams or has a mass of 16 grams. We're going to solve how many grams of sugar is 1 mole of sugar. Let's add those together. Just punch that into a calculator and you get So next time you're watching the Great British Baking Show, and they're like, we're using 500 grams of sugar, and you're like, oh great, that's 500 grams of sugar is like just over 2 moles. You could calculate how many particles are in those 500 grams of sugar. You could totally do that. I don't know if you want to do that, but hey, you could. You have the full skill set to know exactly how many, if you dig down to the tiny little molecular level, how many molecules are in that cup of sugar, in that 500 grams of sugar, in your sugar bowl. That's your tool. That's all you need. For any compound, you can figure out the mass of a single mole, and once you know that mass, you can figure out how many moles and then how many particles. And that's a wrap. that's like all. Like, that's all there is to this. We'll do your first example, just because this one has... Here's how this gets tricky. Ready? Okay, ready. This gets tricky when there are parentheses. So kind of back to your balancing reactions brains. Let's just do this first one. Number 1, wait for the computer. Okay, great. So number 1, we've got magnesium manganate. Oh, yeah, and magnesium's got a charge of +2. Manganate is -1, so we need 2 of those to make a neutral compound. All right, so you've got your neutral compound there. And we'll do it the same way. We've got 1 magnesium. Here's where it gets a little tricky. The 2 subscript is on the outside of the parentheses, so it distributes to all of the stuff inside the parentheses. So for manganate, we have 2 manganate. That's how it got tricky. And oxygen, we've got 4 times 2, 8 oxygens. We're now done with the tricky part. The rest of it looks the same. Now you're looking for magnesium. There's magnesium. Molar mass of magnesium is 24.31. 24.31. And manganese, I guess the other tricky thing here is Mg and Mn are like 2 different things, even though they sound super similar. There's your magnesium. There's your manganese. 54.94. And last but not least, your oxygen. Oxygen's over here. You'll always have this with you. There's no reason to memorize any of this. You may start to memorize some things that you see a lot. You can make some guesses of the elements that you see a lot. You do not see manganese very often. Don't worry about that one. But oxygen comes up pretty frequently. Oxygen likes to stick to stuff. Just doing some multiplying here. We've got 1 mole of magnesium. That number will stay itself. We got 2 moles of manganese, so 2 times 54.94 is that. And 8 moles of oxygen. There you go. That's the mass from the magnesium, that's the mass from the manganese, that's the mass from the oxygen. Add them all together. 24.31 plus 109.88 plus 128. I just set the wrong key, that's fine. And yeah, that looks right. 262.19 grams per mole. Same with yesterday's stuff. That unit is totally key. You maybe even are looking at that unit and thinking, I bet tomorrow we're going to have to take things from grams into moles, or from moles into grams. You are totally correct. That is what we will do tomorrow. So yes, that unit does matter. Both the number and the unit are your keys here. But that's all. That's all. You've got this page here. Try any 6, including at least one more with parentheses. So just give yourself a little practice with the parentheses. If you're grooving with it and you want to crunch them all, go for it. Yeah, they all have the units of grams per mole. Ask if you've got questions. Yeah, I'll just show you this again, just in case you want to see any of this. Your steps every time. We wrote down the steps on the other slide, or other video. Figure out which elements you have, how many of them, the mass for a single one of that thing, the total mass. So single mole of carbon is 12 grams per mole, but we've got 6 of them. So altogether, that mass is 72.06 grams per mole. Same thing with the hydrogen. We have 12. Each one of them has that mass. Altogether, they have that mass. So for each of the elements, add them up. That's your answer. I'll show you this one too. And then you'll choose any 6, including another one with parentheses, and crunch them out. Alright, enjoy.